You could get a question like this on the GMAT or even potentially on the GRE. It says, does the integer k have a factor p such that, in this case, it says 1 is less than p is less than k. Okay? The first thing you got to realize for this particular question is, for p to be a factor of k, the value of k cannot be prime. So what this question is really testing is k a prime number? That's what we're looking for. Is the value of k a prime number? So what we want to be able to say is, yes, k is a prime number, or no, k is not a prime number. So let's go ahead and look at statement 1. Okay? Statement 1 says that the value of k is greater than 4 factorial. Remember that 4 factorial is going to be 4 times 3 times 2 times 1. What this is telling is that the value of k is greater than 4 times 3 is 12 times 2 is 24. So the value of k is greater than 24. Okay? So that means the value of k could potentially be equal to 25. It could be equal to 26. It could be equal to 29. It could be equal to any number. In this case, 25 is not a prime number. 26 is not a prime number. But 29 is a prime number. So in this case, statement 1 is inconsistent because you have k. In this case, k is not prime. 25 is not prime. 26 is not prime, but 29 is a prime number. So statement 1 is insufficient. So I'm going to go ahead and cross that out. Now let's go to statement 2. Statement 2 says that the value of k is such that 13 factorial plus 2 is less than the value of k, which is less than 13 factorial plus 13. The first thing you got to realize is that 13 factorial is really equal to 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's what 13 factorial is equal to. Okay? Based on this information, here's the first thing that you notice. In this case, you have 5 and you have 2. 5 times 2 is going to give you 10. And in this case, you have another 10 over here. So in this case, 10 times 10 is going to give you 100. So you're going to get some number, whatever the value of 13 factorial is going to be a number that ends with, I'm going to put a dot, 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 and put 2 zeros. So whatever the value of that number is, I know it's going to end with 2 zeros. Okay, here's the first thing that I notice. It's going to be an even number. Now if I'm adding 2 or if I'm adding 13, I'm going to get some number, okay, that's either going to end in 2, it's going to end in 03, it's going to end in 04, it could end in 05, it could end in 06, it could end in 07, 08, 09, or it could end in 10, 11, 12, or 13, because I'm either adding 13 or I'm adding 2 to it. Remember that what we're trying to do is prove that the value of k is not a prime number, or is it a prime number? I'm trying to answer that question. The first thing you realize is, if you're adding 2, if the number ends in 2, all the even numbers are accounted for. Even number means that it's not prime. So this would not be prime, this would be prime, this wouldn't be prime, that wouldn't be prime, and that number would not be prime. Also, if it ends in 5, it is not prime. Now notice that the factors that you have within 13 factorial, you have 3, 7, 9, 11, and 13. These are all factors in 13 factorial. So even if you add it to the value of 13 factorial, one of these numbers would still be a factor of that number. So by default, we know that the value of k is not a prime number. So statement 2 is sufficient. So statement 1 is insufficient, statement 2 is sufficient. So your answer in this case is going to be B. Thank you.